Okay, let's give you guys some more practice. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, if you look at this here, this thing here is very similar to minus 1 to the power of n, but here it doesn't matter, as n tends to infinity, so rather than starting your sequence at 1, you can start it at anywhere, let's say 7 or maybe 10, you can start it anywhere. So the point is, this whole thing here is just still going to, well, 1 over minus 1 to the power of n is going to do minus 1 and then positive 1 and then minus 1 and then positive 1 and so on. Well, this thing here is still going to do the same thing, negative 1 and then positive 1. It doesn't matter where you start. It doesn't here. Well, even if it's n to the power of 7, sorry, n plus 7, then this is still going to oscillate negative 1, 1, negative 1 and so on. This thing here is just going to, this thing here is very similar to this thing here, but this thing here is still going to oscillate back and forth. Well, you can imagine this thing here as this. You can say that the sequence that you're looking at, this thing here, the biggest value that this could be is 1. The lowest thing that this thing could be is negative 1. And then looking at this, you can see that the limit of this, well, as n gets bigger and bigger, the denominator here will be very, very big. So 1 divided by very, very big, this is going to head towards 0. This is also heading towards 0. We don't know what this is happening, but we do know that because it's trapped in between 0 and 0, the limit of this must head towards 0. So just by looking at this now, up here, just by looking at it, you can tell, well, in your mind, just know that this has to be 1 and negative 1 and 1. It's just going to oscillate between the two, and then you know that the denominator here is going to get very, very big because of this. So even if it's negative 1 divided by very, very big, it's still going to be 0. Even if it's positive 1, you divide it by very, very big here, it's still going to head towards 0. So just by glancing at this, you can tell it's heading towards 0. So the limit is actually 0. Okay, next question. So find the limit of this sequence as n tends to infinity. So press pause and have a go. Okay, so to do this, as n gets bigger and bigger, you've got the numerator here as being 3n, and then as n gets bigger and bigger, this thing here is going to be massive, and you're taking away a tiny amount, so you can forget about that tiny amount. You can forget about that tiny amount. So the denominator, as n gets bigger and bigger, you can think of the denominator as this, and then here here the two ends will cancel each other out. So that would be 3 over 2. So the limit is really the square root of 3 over 2. So if you get a graph plotter and plot this, the limit is actually square root of 3 over 2. So the limit is this. Okay, so next question here, the same as before, but this time everything's exactly the same except here you got squared. So what would be the limit of this? Okay, so press pause and have a go. Okay, so to do this, the limit of this, so now you've got this squared here. So as n gets bigger and bigger, you can think of this as being this bubble here. But then as n gets bigger and bigger and bigger, the denominator here, you can forget about this small amount. You're taking away a tiny amount as n gets bigger and bigger. So you can think of the denominator here as being 2n. So you can think of the denominator here as being 2n. So as n gets bigger and bigger, you can imagine this fraction as this. So now divide top and bottom by n. So that will then give you this. So now remember, well, visualize this as being one block multiplying another block, and remember that equals root a root b. So basically it becomes that, and then now this here, this is a constant, so you can take the constant out. That will then give you this, and then you've got your limit here, square roots. And if you look at this, square root of n looks like this. So well, this is y equals square root of x or n, whatever you want. But the point here is that as n gets bigger and bigger, the square root of n will keep on climbing. It will just get bigger and bigger. So this thing here is heading towards infinity. So this thing here is just going to get bigger and bigger and bigger, and then you times a constant, it's just going to get bigger and bigger and bigger. So the limit is well, there is no limit. The sequence diverges. Okay.